Welcome back, everyone. Hopefully you've had a chance to go ahead and have your own go at the capstone project. Now we're going to go through the solutions, and this is part one of that series of lectures. Keep in mind that a lot of the visualizations and tasks can be done many ways, so don't worry if you didn't do it exactly as we did, or if your visualizations don't match up precisely to ours. As long as you're conveying the basic idea that we are, that's totally okay too. So let's head over to the notebook and get started. All right, here I am at the capstone project. So hopefully you already were able to read the article, and after reading the article we have these two data sources, and what we're going to do is start off with the first task, which was to import any libraries we think we may need, and obviously you can import as you go along as well. I know I'm going to be using Pandas, and I also know I'm going to be doing some visualization, so I will import Matplotlib.pyplot as PLT, as well as import Seaborn as SNS. Okay. So after running those imports, let's go ahead and move on to exploring Fandango displayed scores. So we read this Fandango_scrape.csv, and let's explore the actual Fandango data frame. So if we check out the head of the data frame, we can see here it has the title of the film, and in parentheses it has the year the film came out. It has the stars displayed, and recall stars displayed is what the user who visits the website actually sees, and then rating is the true film rating. So you notice that Fandango tends to round up the rating in order to display stars, which for the most part kind of makes sense because it's difficult to show 3.9 stars if you can only fill in a star wholly or halfway. So we then have the number of user votes. We can also say Fandango info to see how many rows we have. Looks like we have 504 rows, and then we can also say Fandango.describe to see any statistical properties, such as the average stars versus average rating. You'll notice stars in general tend to be higher than the rating, and then we can also see the standard deviation for these. Okay, so let's go ahead and explore the relationship between popularity of a film and its rating. First, what we're going to do is we'll create a scatter plot showing the relationship between ratings and votes. And as we mentioned here, don't worry if your plots in general don't look exactly like ours. You can always adjust it to your preference. But what we're going to do here is create a scatter plot. So one easy way to do this is with an SNS scatter plot. I say the source of my data, and I'm going to zoom in one level here so we can see it, is Fandango. And then what do I want on my y-axis? Well, we'll go ahead and say votes. And then on the x-axis, we can say rating. So just running this should get you the basic scatter plot that we showed here. But something else you can do is start adjusting this either with Matplotlib or with Seaborn to try to change the size. Notice it's kind of small and it's a little blurry, so something I did here is I just called plt.figure, and I said fig size is equal to 10 by 4, and I also increased the DPI just to make the image a little sharper. Obviously you have a lot of leeway here, you don't have to sharpen the images like this, but this matches up with what we had in the solutions. Okay, next is to calculate the correlation between columns. We've already talked about this a few times, so all you need to do whenever you're faced with this challenge is just call CORR, open and close parentheses, and every numerical column is then have a correlation calculated against all the other columns. And probably what's most telling here is that stars and rating are not perfectly correlated. That means there is some sort of discrepancy between the stars being displayed versus the rating being shown. Now in general, the correlation is extremely high, which makes sense. If you have a large rating or high rating, you'll have a high stars. If you have a low rating, you'll have low stars. But it's not perfectly correlated, meaning there is some difference between the stars being shown to a user versus the true numerical rating. So the next task was to actually extract this year. So assuming that every row in the film title column has the same format, so we saw up here that it has the film title and then in parentheses the year, this task is going to ask you to actually extract that year using any of the methods that we learned so far. So we can use any of the .str methods to try to do this, or you can also create your own custom function. But one way to do this is with a lambda expression. Keep in mind that if I have something like this, film title name year, if I set that to my title, so I'm going to put in parentheses or in quotes here, film title name year, what I want is what's inside year. There are many ways we can do this. The way I did this was I'm just going to split based off the first parentheses. So if I split based off the first parentheses, suddenly what I have here is the film title and then the year with a parentheses afterwards. And I just want this last item, so I'm going to say off of this list, index at -1, which gets me the last item in the list. And now I have this year. However, I still have this issue of that parentheses, so I can simply say replace this closing parentheses with an empty string. And that should work to get me the year from the title, assuming they're all formatted this way. And we told you that to make that assumption, which means that I can do the following. I can say from the Fandango data frame, create a column called year, and that's going to be equal to the Fandango film column, where I'm going to apply a lambda expression. You could also apply this as a function, but I'm just going to say title, and then I'm going to do what we did here, title, replace, and then copy that, and go ahead and run this, and then we should be able to see off Fandango that we have this year column. Keep in mind, right now this year column is a string, but for our purposes, we don't actually need to translate this to anything else. All right, so we have that ready to go for us. Let's go ahead and move on, and it asks us how many movies are in the Fandango data frame per year. This is really easy to do. Once we have this column, I can simply say Fandango, the year column, go ahead and do value counts on it, run this, and you should notice that pretty much all these movies are from 2015 or 2014. There are just a few other movies from 2012, 2016, and there's kind of this random movie from 1964. But these results here are exactly the same as these results. It's just that they're in a slightly different order here on the bottom, but overall the results are the same. Next, we wanted to visualize the count of movies per year with a plot. Super easy to do with a seaborn count plot. We simply say sns.countPlot. The data is the Fandango data frame. And then I'm going to say that x is equal to year. Run that, and here we have it. Same information shown here, but visually. Okay, so you can always edit this sizing, but this is probably enough for our use case. What are the 10 movies with the highest number of votes? One way to do this is to either use sort values or n largest. I'm just going to grab Fandango again and say, give me the n largest 10 based off of votes. So essentially, grab the 10 rows with the highest or largest values for votes. And in this case, the data frame is actually already sorted by votes, so you should see what is essentially the same thing as calling the head of the 10 rows of the data frame. But you don't want to assume that it's sorted by votes, just actually manually grab it. So you can say sort values, grab the first 10, or n largest, grab the first 10 based off of votes. So here we can see the most popular movies essentially of 2015, and then 2014 Into the Woods. Moving along, how many movies have 0 votes? Lots of different ways we can do this. One way is to simply say, take the Fandango data frame, take the votes column, and check where is it equal to 0. So if it's equal to 0, that means we have this Boolean series, which means I can then either take the sum of this. So I could say no votes is equal to the series of Boolean, and then say no votes.sum, and it treats the trues as 1s and the falses as 0s, and it gets me the result of 69. Or what I could also do is say Fandango, and then only grab movies here, and you'll notice it also reports back that it's 69 rows, which means I could have just checked the length of this to get 69 as well. Lots of different ways we could have answered this. Next was to create a data frame of only the reviewed films by removing any films that have 0 votes. So I'm just going to say fan reviewed is the name of my new data frame, and it's the Fandango data frame where the let's make sure we spell that right, the Fandango votes column happens to be greater than 0. Okay, so I have this new data frame of things that actually have more than 1 vote, or excuse me, more than 0 votes. And as noted in the article, so if you read the 538 article, due to HTML and star rating displays, the true user rating may be slightly different than the rating shown to a user. And so what we want to do is visualize that difference between the true numerical rating versus the stars actually being displayed. Now, there are many, many ways you can compare these distributions. In fact, you could have done this with pure Matplotlib if you wanted, but the way I preferred to do it was with just 2 KDE plots shown in the same cell. That way it would stack on top of each other. Again, there's tons of different ways you can do this, so do not take this as the only way that this is possible. But something I just did is I said SNS KDE plot. I'm only interested in things that actually have a rating, so I'm going to use that data source as that fan review data frame I just made. And first, let's just go ahead and grab the rating column. And if I just run this, notice what happens. I can see the rating itself. Okay, so a couple things I want to do here to start editing this. One thing, you'll notice it extends beyond 5, and it also may extend beyond 0. So I want to clip this KDE to only go from 0 to 5, because that's really the only possible ratings for my stars. So now we've clipped this from 0 to 5. And then what I also want to do is I'm going to shade this in by saying fill is equal to true. And just to make sure if I add a legend later on to know which one I'm looking at, I'm going to describe this as true rating in the label. Okay, so we have this rating in the KDE plot, but I also want to compare it to the stars being showed. One way I can do this, I'm just going to copy this, and then I'm going to paste it right below. But here, instead of X, what I'm going to say is stars, and then the label for this one is going to be stars displayed. We run that, and now we can begin to see the actual ratings compared to each other. But right now, because these are two separate seaborn plots, I'm not actually seeing this label. To see that label, we know that I have to say plt.legend. And let's go ahead and move this legend to somewhere outside of the actual plot itself. So I'm going to say the location of this legend is equal to, let's say 1.05, 0.5, run that, and I can begin to see the legend. And finally, if I want to make this a little larger and a little sharper, above all of this, I can say plt figure, fig size is equal to 10 by 4, DPI is equal to, and then you can just make it a little sharper with 150. Okay, and these are the exact settings we used for our diagrams. Of course, you can use pretty much any method here that's available to you for distribution plots. It doesn't have to be KDE. It's just the way we decided to show this relationship. And we're going to move along and then actually quantify this discrepancy. So let's create a new column between the difference of stars displayed versus true rating. And we're going to calculate this difference with stars minus rating and then round these differences. So that means we're going to do something like this. I'm going to say, we're going to do this off the fan reviewed, since the other ones don't have any reviews, so they don't really have a rating. We're going to say stars diff is equal to fan reviewed stars minus fan reviewed rating. And you'll notice that you may get an error here. It's not truly an error, it's just a warning. And this warning is essentially reminding you that fan reviewed is technically a copy of a slice from a data frame. So what that means is it's essentially reminding you that fan reviewed actually comes from this Fandango data frame. So in case you didn't want that, you could have also made a full copy. But for our cases, we don't actually need to worry about this. There's a full set of caveats in the documentation. This is a very common warning to get. Again, it's just a warning. Everything actually still occurred here. In fact, if I take a look at fan reviewed, we're still okay. I have the stars difference here. So keep in mind, this is a really common warning you're going to see. For this use case, I don't actually care that this is a copy of a slice from a data frame. I am aware of that. But you can always use the .copy method in order to make sure you're creating an entirely new data frame to work with. Keep in mind, the more copies of a data frame you create, the more RAM memory you're taking up. Okay, so we have this fan reviewed. Right now, stars diff, the last thing I want to do is make sure that this is rounded off. So I'm just going to say the following, that stars diff is equal to fan reviewed. And there's many different ways you can actually round this. So we'll say stars diff. I'm just going to call the round method that's available to us in Pandas and say round this to 2 digits. Again, it's going to warn us that this is a copy. That's totally okay, as long as I can check out fan reviewed and get the same results here. So you notice that these differences, for some of them, or quite a few of them, tend to be 0, which makes sense that if the rating has 1 vote for 5.0, the stars that is going to be shown is just 5.0. So after that, we're going to create a count plot to display the number of times a certain difference occurs. So the difference is here. I want to see how many times is the difference 0.1, or how many times is the difference 0, 0.2, and so on. The way we can do that is with a simple count plot. We simply say sns.countPlot, data is equal to, in this case, we'll use the fan reviewed data frame again, and the x that I want to count is stars diff, and I went ahead and chose the magma palette because it was a little easier for me to see. Obviously, this is totally optional. So you run that and you get this comparison. If you want to match up exactly with the solutions, we went ahead and edited this figure a little bit. We just changed up the size. We said fig size is equal to 12 by 4 with a higher DPI. So what does this plot actually mean? How do I interpret this? Well, this means that we have about a little over 100 reviews where the true numerical rating is the exact same thing as the stars being shown. But take a look at this. These are all differences in stars. In fact, we have a color bar, even though it's tiny, at 1, which means there's actually one movie where the stars being displayed is 1 higher than the true rating, which is kind of crazy. So what movie had close to this 1-star differential? The way to do that is by simply filtering it. So what I want to do here is say fan reviewed, where, whoops, make sure we spell this right, where fan reviewed, and then we'll check out the stars diff column. Where is it equal to 1? So you run that, and so what's kind of crazy here is that for the film Turbo Kid, even though the user rating between 2 users is 4.0, if you went to the Fandango website in 2015, it would have said that it was rated 5 in the HTML. So you would have seen that 5-star bar all the way filled up, even though 2 users, their average rating was 4. So it's kind of a crazy difference of 1 star, considering our scale is only from 0 to 5 stars. And what's also kind of different or unusual here is that there are more movies that we are actually displaying a different set of stars than we have total matches. Because notice the sum of all these colored bars that are not at 0 should definitely be higher than the total count of 0. That means on average, we are definitely showing a higher rating in the stars than the true rating behind the scenes. Okay, so that's it for this part of the solutions. In the next video, we'll continue on with the next part, which is the comparison of Fandango ratings to other sites. I'll see you there.